Hello children, welcome to aimstoday online classes. This is a chemistry session. Here we are discussing about acids, bases and salts. In this session, let us see about the properties of bases. In the earlier sessions, we have discussed about what are bases, how they are categorized and their physical properties we have seen. In this session, we are going to discuss about the chemical properties of bases and their uses. Okay. So sodium hydroxide and potassium hydroxide, they do not decompose on heating. However, they melt when strongly heated. So generally, metal hydroxides on strong heating, they decompose to form metal oxide and water. But especially these metal hydroxides like sodium hydroxide and potassium hydroxide, they do not decompose. Even after strong heating also, just they will be melted off, but they won't be decomposed. And some other metal hydroxides are basic hydroxides like ammonium hydroxide. On heating, it decomposes rapidly and form ammonia gas and water. Say this is a ammonium hydroxide, NH4OH. This on heating, it decomposes to form ammonia and water. Okay. And all of these metallic hydroxides except certain like sodium hydroxide and potassium hydroxide, the remaining metal hydroxides, they decompose on strong heating and they form their respective metal oxides and water. For example, this is the general equation for metal hydroxide decomposing into metal oxide and water. For example, if you see calcium hydroxide, on strong heating, this decomposes to form calcium oxide and water. So we generally say this as lime water, calcium hydroxide or slaked lime. This on strong heating, it forms calcium oxide, which is also known as quick lime and water. And neutralization reaction with acids. Bases generally they react with acids to form salt and water. When acid and base they react each other, they form generally salt and water. This kind of reactions in which acid and base they combine together to form salt and water are called neutralization reactions. For example, we see here sodium hydroxide, which is a base. Sodium hydroxide is a base and it reacts with an acid called here hydrochloric acid. So this base and salt, the acid, they react each other. They form a salt called sodium chloride and water. So this sodium chloride is also called as common salt or table salt, which we use in our food items, okay, in our homes. So in this way, bases on reaction with acids, they form salts and water. These reactions are called neutralization reactions. And reaction with metal salts. Strong bases they react with least reactive metal salts to form salt and the hydroxides. For example, if you see here strong base sodium hydroxide, it reacts with one of the salts like copper chloride to form sodium chloride and copper hydroxide. And reaction with ammonium chloride, just like the metal salts. Here, bases react with ammonium chloride to form metal salt and ammonium hydroxide. If you see here, the same strong metallic hydroxide, sodium hydroxide, on reaction with ammonium chloride, it forms sodium chloride and ammonium hydroxide. Now let us see the uses of these bases. Where do we use this? We see one of the bases, ammonia. So it is used in the production of fertilizers, and it also used in the manufacturing of nitric acid, and this ammonia is also used in the neutralization of acid. Generally in the petroleum industry, it is used in the neutralization of acid. The most important use is it is used in the production of fertilizers. Okay. Next, aluminum hydroxide. This aluminum hydroxide is used in the manufacturing of other aluminum compounds, and it is also used in the making of gastric medicines like antacids. Okay. And next, calcium hydroxide. It is used to make cement, lime water, and it is also used in the neutralization of acidity of soil and in application of sewage treatment. Okay. Next is sodium hydroxide. It is one of the strong bases we say. It is used in the manufacturing of soaps, detergents, and even in cleaners. Next, magnesium hydroxide. This magnesium hydroxide suspension is used as antacid. That means suspension of magnesium hydroxide in water is used as antacid. This suspension of magnesium hydroxide in water is also called milk of magnesia. Okay, this milk of magnesia is used as antacid. That means people suffering with acidity, they use this medicine, this magnesium hydroxide solution as medicine to get rid of this acidity effect. So when it is taken, it reacts with the excess acids present in our stomach and it neutralizes them. So this magnesium hydroxide suspension in water is called as antacid. It is also used in making of deodorants and as a non-hazardous alkali to neutralize the acidic wastewater. So they are the uses of magnesium hydroxide. Next, let us see what is meant by neutralization. Just now I have seen the reaction in which an acid reacts with a base to form salt and water as products is called neutralization reaction. So this is a generalized equation for it. Acid reacts with base to form salt and water. For example, if you see very frequently used acids and bases, hydrochloric acid and sodium hydroxide. When these two react each other, they form sodium chloride and water. Neutralization reaction is used in the preparation of salts. So as acid and base they react each other to form salt and water. So in the preparation of these salts, these neutralization reactions are frequently used. And also in countering harmful effects of acids and alkalis. So unexpectedly if acid fallen on the skin, then it can be neutralized with a certain base so that we won't get harm of this. In this way, in countering the harmful effect of acids and alkalis, we use this neutralization reactions. And now let us see about indicators. Indicators are organic dyes that have one color in acidic solutions and another color in basic solutions. Generally, these indicators are of two types. One it is common indicators, another one is a universal indicator. Okay, generally these indicators are used to detect acids, bases, and salts in the laboratory. These indicators give different colors with different acids, bases, and salts. So generally we use common indicators and universal indicators. The most common indicator used in the laboratories is litmus. It is extracted from certain plants, namely lichen. From these plants flowers, this natural indicator litmus is derived. It is dissolved in alcohol to get a solution called litmus solution. Okay. As we told, the common indicators used in the laboratory are litmus solutions or litmus papers, methyl orange, and phenolphthalein. Just now I told, litmus is one of the natural indicators. It is available in two colors, blue litmus and red litmus. It is available in the form of either solutions or it is also taken in the form of papers in the laboratory. So litmus papers will be in two colors, blue litmus papers, red litmus papers. Along with this litmus, there are some other indicators which are commonly used in the laboratory. They are methyl orange and phenolphthalein. Using these indicators, it is possible to identify either acidic, basic or neutral solutions in the laboratory because almost all these solutions they appear colorless in the laboratory. They seems like water. But without detecting them, without identifying them, we cannot use for the chemical reactions. So before using them, we have to identify whether it is an acid, base or a neutral substance. So this can be identified by using these indicators like litmus, methyl orange and phenolphthalein. When a few drops of blue litmus solution are added to an acid, this turns to red color. So if you take an acidic solution, if you add few drops of litmus into that, blue litmus, immediately the solution turns into red color. This indicates the taken solution as an acid. In the same way, when you drop few drops of red litmus solution into a basic solution, that turns into blue color. Okay. The other common indicators as we have seen here are methyl orange and phenolphthalein. How these can change their colors in the presence of acids and bases. Let us see here. As we told, litmus changes from blue to red in presence of acids and red to blue in the presence of bases. And if we take methyl orange, as its name, it will be in the orange color liquid. When you take few drops of this methyl orange into acidic solution, it turns into red color. The same methyl orange, if you drop few drops into base, immediately the solution turns into yellow color. And phenolphthalein, it is one of the general indicator used in the laboratory, which is a colorless solution. When you add one or two drops of this phenolphthalein to acids, it won't show any color change. Means the solution will remain colorless. The same phenolphthalein, if you take one or two drops into a basic solution, immediately the color changes to pink color. So in this way, these general indicators are used in the laboratory to identify the given solutions as acids or bases or salts. Even we also can make acid base indicators at our home. Yes, not only these litmus and phenolphthalein and all, methyl orange. Some other indicators, natural indicators, we also can prepare at our homes. For example, turmeric juice or red cabbage juice can be used as natural indicators. So if you boil the turmeric pieces or cabbage leaves in water and squeeze the pulp to get its juice, this juice can be used as indicator. Yes, if you take turmeric, if you boil the turmeric pieces in water and if you take the juice of that, the turmeric juice can be used as natural indicator. So if you drop a few drops of basic solution into that turns into red color. In this way, turmeric juice can be used as natural indicator. In the same way, cabbage juice also can be used as indicator. If you take the cabbage juice in the water, it will be in the purple color. If you take these few drops of this cabbage juice into basic solution, that color changes to bluish green. The same cabbage juice, if you add into acidic solution, that turns into pink color. In this way, we also can prepare some natural indicators at our home too. Okay. Thank you for watching our video. Please subscribe our YouTube channel AIMS Today and visit our website aimstoday.in for latest updates on recorded videos.